Good morning, everyone. Yeah. So today we'll be having an introduction to testing, how to test your Cairo programs and smart contracts. There's smart contracts you write using Cairo as well. So particularly is what is Cairo? That's the language you'd be testing. So Cairo is a Turing-complete programming language designed for creating provable programs for stack-based systems. So StackNet uses Cairo as their programming language due to the fact that it's provable for their own virtual machine. That's for the Cairo VM. So another thing about Cairo is that it's designed for performance and security in verifiable computation context. So the idea of Cairo for StackNet was that given a program or giving an output, you could verify it on another computer. Yeah, so this is another thing Cairo offers to them. And then we've already said it's the primary language for writing smart contracts on StackNet. And also it enables provable execution, enhances scalability and security on layer 2. So stack systems are actually, theoretically, they are quantum resistant. So this, through Cairo, they were able to achieve something like this as well. Yeah. So why we are here today, and here's a question here: why should you test your programs? So I mean, you could just write your code and tell your users to trust you that your code works. But then the blockchain ecosystem doesn't actually work like that. So one of the reasons is that smart contracts are immutable. So the blockchain state is immutable. So a contract you've deployed is often difficult to upgrade. That's to go back and change it if you discover a flaw or a logic error or a bug or any vulnerability. There are cases where through upgradable contracts, you might be able to fix what happened. But then if you affect the storage slots, that's your memory storage, then the smart contract will most likely not function as it was at first. And then this leads to bugs being either permanent or impossible to change. So another reason why you should test your Cairo programs is smart contracts, most likely, or most at times, they help transact financial assets. So yeah, you'd have digital assets like ETH, Stack, USDT, whichever. So your contracts frequently manage valuable assets, and then a bug could lead to a vulnerability that an attacker could take advantage of to move out all the funds in your smart contract. And then another reason why you should test it is that the users of your smart contract actually trust or entered into that contract agreement with you because they believe your code should work as you specified it to work. So it's your own duty or due diligence that you've tested your code and then you are sure that it performs everything you asked it or you guaranteed it will do without any flaw. And then another reason why you should test is that when contracts start to make interactions with other contracts, e.g. now your smart contracts interact with an ERC20 smart contract, the complexities that involve through those multi-contract call could either lead to a vulnerability you didn't check for or a bug you didn't account for. So if you test, you are able to detect these kind of bugs or issues at development, not in production. And then common risks why you should test, e.g. logic errors. So there are cases where you see off by 1. So maybe you are checking greater than or equals to. And then an attacker takes advantage of that greater than or equal to logic you had and then keeps taking, keeps stealing or produces a reentrancy bug in your contract by taking advantage of that logic error. Another could be access control. So contracts introduce access control to, your smart contracts, when deployed, it's available on the blockchain and anyone could read or try to change the state. So if there's anything about it you don't want anyone to have access to, you could role base the access by saying, okay, only the owner or only certain group of people should be able to make state change. So if you didn't properly test that your state change is being gated or guarded by access control, then somebody somewhere someday might just take control of your smart contract. Another reason why you should test is arithmetic overflows or underflows. So a case where this might bite you is if you are managing digital assets for people and you didn't check what happens when the particular asset you are managing exceeds the maximum value. It could overflow and then wrap and start from 0 or 1 again. And then people have lost everything they had due to that overflow error you didn't check for, or underflow. Another could be gas issues. So your contract might be too expensive for people to use. So when you test, you see, okay, how can I optimize this? Because the test frameworks, they actually show you an estimate of the gas used when interacting with your contract or a specific function in your contract. So you could check and say, okay, how do I optimize this to consume less gas and to be more friendly for the users? So that's one reason. And then to check that your contract, another kind of hack, reentrancy, that your contracts cannot, replay attacks cannot happen on your contract. So what are the testing frameworks available for Cairo or for people building in Cairo? So there are two primarily used testing frameworks. We have cairo-test and we have SNForge. So cairo-test is Cairo's native test runner. So when you install the Scarp plugin, the cairo-test is bundled alongside the Scarp toolchain. So anytime you do Scarp cairo-test, it uses the Cairo native test runner to test your code. And the other option is SNForge. So SNForge is part of the StackNet Foundry toolchain. So Foundry, just like Foundry in Ethereum, StackNet Foundry was inspired by Foundry, and then they built this particular toolchain for developing on StackNet. So SNForge is actually more comprehensive, like it offers more features compared to cairo-test. So you're able to fork the blockchain state, force your tests, use cheat codes, use OM. You could cheat the block timestamp, you could cheat the block info, stuff like that using StackNet for Foundry. But then that's SNForge. But then with cairo-test, when you want to do things like this, you have to manually recreate those particular instances, which could be more tedious or slower compared to just using SNForge. Yeah. So just a quick overview on cairo-test. So cairo-test is the native test runner, and then it's ideal for unit testing. So when you just want to, maybe you're building a library and you just want to quick test, like for every iteration, you just want to see how your function plays out. So you could just use cairo-test and you keep running all your checks and tests as you develop. And then it allows you to test private functions as well. So there are cases where maybe people would say you shouldn't test private function or you should test private function. So since when you are running unit tests, they're actually bundled alongside they are typically in the same file with the function you are testing. So it's easy for you to, through the module system, to be able to, okay, you could see private functions if you want, or expose them using a public interface and then test that public function that calls the private function. So you could do that as well with cairo-test. And then cairo-test actually collects or sees tests as functions marked with the test attributes. And then it collects them when you run the test command. So if it goes through your, if it goes through your module or your files or your crates, and then it sees functions marked with the test attributes. So it compiles them and then runs the test code for them and confirms that your tests actually assert or do what you ask them to test or check. So there are macros that are provided for you. So there's the assert macro you use to check if a condition is true. And then there are other macros from the assert macros package. So the assert macros was separated from stacknet because it takes more steps, or it takes and consumes more gas when you use them. So that's why it was pulled out. So if you actually want to use them when testing, then you import them as an external dependency in your dev dependencies. Yeah, so it offers you macros like assert equals, assert not equals, assert less than or equals, and then assert greater than or greater than equals. So here's the way you use cairo-test. So you typically have your function, and then maybe you set up the data inside, the data you want to test, and then you call the function you want to test, and then you call your assert functions. Okay, assert that the condition you are testing for is actually what you expected it to be. So tests typically work like this: what you expected, what you got, comparison of both of them. Is what you expected equals to what you got? If it's not, then the test failed. If it is, then the test passed. So that's where you use your asserts to assert that, okay, did what I get, is it equal to what I expected? So if it is, then there's no need for panicking and then sending out the error message. But if it's not, then it panics and then it gives out the error message that, okay, what I expected is not equals to what I got. So you typically put your test functions inside the module in your code file, and then if every code in your file gets compiled when you run scarp build, so when you build your program, every code it comes across gets compiled. But if you don't want to compile your test alongside your actual program to reduce the artifact size or the build size of the binary of your program, you annotate your test module using this CFG, that's configuration attributes, and then you specify test. So this particular module should only be compiled when I run scarp test. So only when you see the test command that you should compile this module. So this particular module, there's just a test file, there's just one test function here, and it's testing an addition function. So you typically define your functions you want to test outside the module, and then inside the module where you write your test, you import the function you want to test. So here, they are testing if they have this, they are expecting that 5 plus 10 should be equals to 15. And then they call the add function from above and says, add A plus B, add A and B. So if what you get from adding both of them is not equals to 15, then you throw this error that says addition failed. But if they are equal, then this particular line doesn't get run. So it's just like your revert statements in Solidity that checks a condition. So if the condition passes, it continues. If the condition fails, yeah, it throws the error. Sorry, are we together? Are we together? Oh, okay. So you typically use cairo-test maybe when you are testing your pure functions. So those doesn't really require interacting with the smart contract state or the blockchain entirely. So you typically don't have to set up the whole states condition required for that test to pass or fail. So if you are typically maybe testing a smart contract with cairo-test, you'd have to mimic the smart contract state, the blockchain state, the values you want to actually test against that particular smart contract with that function, and then the blockchain network, maybe if it's testnet, devnet, or mainnet. But if it's just maybe a library function you're testing, then you could typically just use your cairo-test. So here is a function that calculates fees based on a certain basis point and the amount you are passing inside. So it just converts the fee into so it converts it from U16 to U256, multiply it by the amount, then divide it by 10,000. So if you come back, so now here we are testing that, okay, given this amount and this fee basis percent, so do I get the actual 0.5 I'm expecting? That's when I test it through when I call this particular function. So they pass amounts and then they pass the fee basis points. So do I get 5 or not? So if calculate fee goes through this and says, okay, 1000 times 50, you get 50,000, and then you divide it by 10,000. If you don't get 5, it means the function was flawed, so it doesn't do what you expect. So this is one place where you use test. Okay, verifier asserts that what you want is what the function does. That there's no logic error, there's no bug, or there's no flaw in the logic being executed in the function. So typically we've talked a bit on cairo-test. So I think we should do maybe like a little hands-on to see how cairo-test actually plays out. Okay. So like I said earlier, if you actually want to test inside your, if you actually want to run unit tests, so you typically put your unit tests in the same file alongside the functions you want to test. So you actually annotate the particular module where your test should be with the CFG, that's the configuration flag that says only check for tests. That's only compile this module when there's a test. And then you name your module. So if there's a function outside this module you want to test, you'd have to import it inside the module and then you run your test. So for example, let's say we have this function here and we would like to test it by saying, okay, if we provide a value, is the value actually greater than 50? If it's not, so if it's greater, we expect true. If it's not, we expect false. So let's test this and see how it goes. So if the difference between a test function and a non-test function is you annotate a test function with the test attributes, and then you come down, you then whatever you name your function, but typically it's, do I say it's best practice or idiomatic that if it's a test function, you name it, you start with test and then the name of the function you are testing. So when testing, you first of all set up the values you actually want to use in your test. So maybe I say I have a value here. So now I've introduced a test that should fail. So we see like what it's like to have a failing test and a passing test. So here the value I'm introducing is 3, and then I'm saying I'm expecting 3 to be greater than 50. So we pass the value inside this function and check, is 3 greater than 50? The value returns false, and then we are comparing now. Is what this value we got false, is it equals to true? They are not. So it would assert that it will panic and throw this error that 3 is not greater than 50. So here now it's showing us the function that passed and the function that failed. And then it's showing us why it failed. So, and then the error message why it failed. So the error message is 3 is not greater than 50. And then how did it come across 3 is not greater than 50? So there's this true equals false. It's comparing two different values. 3 is not equals to false. So because that condition didn't pass, so because the condition you are asserting didn't pass, then it panics, and as it panics with an error message, which is this hex that is deserialized to 3 is not greater than 50 down here. So for us to fix this, we either change this to false or we change the value we are testing with. So if we go back now and run the test, so you can see that, okay, both tests pass now. So 3 is less than 50, 76 is greater than 50, so none is failing. So we could introduce another function that we like to test, e.g., let's say maybe a function that reverses a given word into, so you give it a word, it reverses it. Yeah. So if you send a word into this, what this function does, it just calls the reverse method on the byte array struct, and then it reverses all the characters in the word so if it's in 0, it flips it to 1. If it's in, yeah, that's what it does. So it just flips the last to the first, second last to the second, all true. So here now, this looks like it works, but you don't trust the code. You only trust that your tests that pass. So yeah, we come here now and say, okay, we want to test this particular function. So we import it here as well. So we annotate it with test. So we'll start with a tricky example, e.g., like a word that's a palindrome. So a palindrome is a word that, if you reverse it, it's equal to the actual word it is. Yeah. Let's see something that's, so this is a name, Lawal. So think our instructor, yeah. So if you reverse Lawal, you still get Lawal, yeah. So we are checking given this word lawal, when we reverse it, we should get back lawal as well. But then if this particular function returns something else other than lawal, then we are to assert or throw this panic with this error message that this particular word we gave you is a palindrome. But then when you reversed, it was not equal to the actual word we sent at first. So yeah. So seeing that what we sent in is also the same as what we are expecting, we could actually eliminate one of these and yeah. So what happened here is that this particular type doesn't implement copy traits. So you can't copy it across. It only gets moved. That's ownership and borrowing. So when I sent it into this function, it was moved inside the function, but then I'm still trying to use it outside the function here. So the way for me to still have it is by cloning it, yeah, or taking a reference, or that's a snapshot. Yeah. So here, after I get the value back, I'm now comparing both of them. What I got is equal to what I expected. If it's not, then throw that particular error message. So we come back to test and see if our function works as expected. So the reverse actually worked. So if you notice now, we are trying to test a particular function, but then everything is being tested. So the test framework offers you a way to filter tests or test a particular test if you're interested in just testing a particular test. So I'm interested in testing this particular test. This guy doesn't support that. So what this command does is that it filters the tests, and only tests with name that matches this particular test you are trying to test gets run. So you could see everything, like all the commands offered by this cairo-test by running this help command. So it shows you everything. You could test a package, test the workspace, filter the test you want to. So if you ignore a test, that's you don't want to test a particular test. You could either run tests by including the ignored tests or test only the tests you've ignored. You could test a particular kind, and then it does everything like when you run this usage command. So like, let's say instead of filtering, I just want to ignore these others. So I'll just come here and say, ignore this. Ignore this as well. And then run our scarp cairo-test. But if you notice, you saw that took more effort than actually filtering a test you want to run. So that's why they provide a filter function for you. So it shows you that, okay, you ignored 2 tests and you only ran one. So the message will be 1 passed, 0 failed, 2 ignored. So like I said, if you want to test only ignored, yeah, so it only tests the functions you ignored and left the one you didn't ignore. So like you could choose to include ignored. So this tests everything, including the ones you ignored. So is it any questions so far? No, I just so it's actually the way testing actually works. Like you're expecting something and then you got something. So I just give it those variable names to be. So I could change the variable names to be anything and it will still work. So they are not keywords. Yeah, you could have as much as you like. But eh? if you have if you have multiple assertions and one fails, the whole test fails. Yeah.
It is testing until you have expected words like 2 times 2 in your test. If you want to test a function that has multiple assertions, you still declare all the variables that are in your test.
Okay, most times you really don't have to declare variables, but I'm trying to be explicit for educational purposes. Yeah. So you could just like maybe here now you put true directly or whatever, so you don't really have to declare variables. Yeah. So we could even do like maybe and then so I'm creating like multiple values I actually want to test. So come down here and do so inside here now just keep checking that. So inside here, I want to check if every value inside here is greater than 50. But we know that 49 is not, so that will be false. So let's actually run it and see what happens. So we go by, for every value in it, assert so for every value in here, check that that value is greater than 50. So it's greater than 50 returns a boolean. So it's either true or false. If it's true, it doesn't panic. If it's false, it panics. So this will run 1, 2, 3, 4, 5 times. So now let's actually test just this particular one. Actually, both of them will go. So let me remove this signal. So it failed at a point where value is greater than 50. So if you actually need like context, then maybe you would have to use like the assert macros. So when you use the assert macros, you could actually use, you could dynamically generate the failure message. Yeah. So I think, let me check this cap.toml if we have it already. Okay. Okay, sorry. It didn't spell. Let me. So notice now we now have these macros, EQ, GE, like after I've added a assert macro, yeah. Well, actually in the wrong test. So we come back here and say, okay, use assert, EQ, so you are comparing what you got from here to this particular. So this particular value is expected to be greater than 50. So this time around now, the panic or the error message would include the value that made it to fail. Oh, I didn't save, sorry. Oh. So it shows you the first point of failure. 50 is not greater than 50. So when it got here, that was when it failed. So maybe I change this now to something like 54. The next point of failure will be 49. So you see, it says value 49 is expected to be greater than 50. Yeah. So you could use those assert macros to actually like use maybe a case like this where you actually want the error message to contain enough context. Yeah, you could use them. But the assert itself just uses felt, and felt has maximum of 31 characters. So you can't actually be as explicit as you want. But these assert macros, they use byte arrays for the error message. So you could go as long as you like, be as explicit as you like here. Okay, yeah. So like this kind of tests are something like table-driven tests where you'd have the value, what you expected. So you could actually use a struct to group them. So the value, what you expected, and then you run them in the loop and then keep asserting that this particular form with this particular value gives you what you expected. Yeah. Yeah. Yeah.
If you do like touch test, this dash VBB to give you more details.
Yeah.
So is there this Cairo now?
Yeah.
Is there an option for that to give you more details?
Yeah, we are.
How to
So we are getting there. I'm just showing you things you can do with cairo-test before we move to SN Forge. Yeah. So an extra function we could test is maybe, let's say a function that given a word, it ciphers the word, that changes, maybe moves, maybe you give it A now and tell it cipher it by 13 more characters. So from A, it changes it to N. And then if you give it to the recipient, he knows that, okay, this word you gave me, if I cipher it again, I get back the A. So I cipher it with 13, I get N. I decipher it with 13, I get back A. Yeah, something like scissor and shake. You know, earlier in the days when maybe generals are exchanging message, or soldiers, armies are exchanging message across themselves. So if they don't want that message to be intercepted, what they could do is that, okay, they could, yeah, they encode it. Yeah, so we'll do something like that. So we could name it probably what? So you actually send a word, and then the number you want to cipher it with. So like the word and then the number you're ciphering with. So the word in this case would be a byte array. The cipher would be maybe a U8, a U32, or U64, but for conciseness, we'll just stick with the smallest, which is U8. So given this word, you would want to do something like, okay, since strings are immutable, like they're actually like a vector of characters or bytes. So you'd actually want to create a new byte that would store the ciphered characters. So the next thing is for every character in this particular word. So So you are creating an iterator over from the first character to the last character. So this is the range that it stops at. So what dot length, but then it stops at 1 before the actual number. So if I include the actual length, then it goes up to length. But typically arrays are 0 based, so it starts from 0. 0 is first, and then it ends at the actual length minus 1. Yeah. So if an array contains 10 items, the first will be 0, the last will be 9. So if I'm iterating, I'm going from the first to the last. So that's 0 to 9 here in this case. So what I'll do is I'll pick out the first, that's the current character. Sorry, it's of type U8 since it's a vector of bytes. So this guy, if you index into this, if you check the docs, you'd see that your byte array is actually a byte of the, so Cairo represents alphabets using the ASCII encoding. So the ASCII encoding of this particular character or value is what you get in this particular index. So alphabets typically start from 65 to 90, that's capital letter A to Z, and then 97 to 123, small letter A to Z. Yeah, so if you get this now, you're actually having a U8, it's either 65 or 90 or 97 to 123. So what you do is, okay, you say this particular character, so if the current character is greater than or equals to 65, and the current character is less than or equals to 90, then you know it's within capital letter A to small a and to capital letter Z. So you could actually just increase it within that bound. Yeah.
So I know the explanation for the number of characters.
Yes. So Cairo represents characters using ASCII encoding. That's American Standard Character Institute, or I don't know those II, but using the American Standard Character encoding, that's what it uses. So they have their table that says, okay, I think I should just pull that up. So see the explanation on how they represent strings in Cairo. So you can you see? Okay. So A is equivalent to 61, stuff like that. So like they use the actual ASCII table to represent it. And here is the American Standard Character. So something like this. Just taking it to the website. So if we come back here, we are saying, okay, if it's within 65 to 90, that is capital A to capital Z. And if it's within 97 to 123, it's small a to small z. So if it's within this, we actually just want to do this particular current character. Huh? Yeah, 65 is capital A. So the current character minus 65 plus cipher so what we now do is that we do a modulo operation that's divided by 26. So if you do modulo, you'd actually go from 0 to 25. And when you get to 26, you start from 0 again. So 0 to 25, 0 to 25. This way you don't go out of the 26 character bounds in that assert table. So if you go out of 26 character bounds, you're either pointing out a character that's not an alphabet. So it could either be the @ symbol you saw just now, or maybe another entirely different character other than an alphabet you expected. So after this, then you add the 65 back. So if it's within this bound, this is what you do. So else, if the current character is from 97 to 123, what you'd want to do is that you'd want to check that, okay, this particular character is A to Z. If it's not, so I come back here and specify I want to return. So it's just like you are moving across A to this, but you are moving within the assert table, that's the character tables. Yeah, sure. Okay. Sir? Is it? No, I don't think they do. So Olowo and this will be what? So no, if you actually cipher it, you should know what you're expecting. So O plus 3 stuff. Yeah. So like it would be maybe if we do 1, we could keep track. So after O is P, M, P, X, P. Yeah, it's passed. So it could like, okay, looking at this, maybe, or maybe not, maybe like you're a maintainer and someone shows you a code like this and tells you the code works, just trust me. You didn't trust the code until you saw it pass. Yeah. So this is why testing is important. Yes, so that's why testing is actually important. So about cairo-test, is there anything like you don't like or understand about it so far? Is it? On what?
Once you use cipher, what did you calculate to get that? The output of that will.
So I'm saying, given this word and this particular cipher, so given a word and a number, I want to shift every letter in that word by that particular number. So if it's A and I want to shift it by 2 characters or 2 letters after A is C. So if you go A, B, C, so I'm shifting A to C. If I'm shifting probably like D by 2 characters, it will be D to E and F. So D, E, F. So I'll stop at F. So that's how it works. You are shifting O by 1. So 1 is P. So you could check that this works again by, okay, given this particular word. Alright. So let's word byte array. So let's try something like the whole character sets. If we shift it by 1, this is what we would get. Eh? Z will be A. So you've shifted by 1 character. Yeah. By what do you want us to shift it? Just.
If you shift Z by 3, it will be C.
Z by 3, so Z goes to A, B, C. Yeah. But computing this is actually like let's just shift it by 26. So full cycle, we get back what we passed in. So we just focus on testing and so if we shift it by 26, we get back the actual characters because we went full cycle. So I think we've had enough of yeah. So let's move to like okay. All right. So we want to actually have a smart